Well, and the synopsis is, at least as long as I don't mess around with ownership, seems to work. I will now do the dirty deed. To deny that currently the directory is as normal. I can edit things. And everything is as it should be. Okay. Now I run the program. Say yes. Now I've actually printed out here the result following the denial. It's probably the same thing. So yeah, this I don't know why this is called an explicit denial, but there is no it doesn't the code says, according to the code that I copied, oh no, it's that one. Deny. No, this is right. Sorry, I changed some of these things to try and clean up a bit. It's not much cleaner, but anyway, I add one of these explicit access things to the list, and it says it should be generic all deny access. But if you look at it, there's nothing generic at all about this. The generics would be in the top nibble. It certainly does standard access all deny, and so I mean I don't know. Everything else is as it was. And you can see in the string there's just that one extra entry, and if I remove that entry, then I would be back to where I was. Well, we'll leave that. Now, I'm not. I don't want to click this thing because I haven't done any tests to do with the owners. I don't even know how to get the owner and set the owner. So, but if I run with the grant option and say yes, now you see that entry is gone, and I can access the directory again, and it's not messed up. Everything is back to normal. Now, that did not require any walking the directory tree or anything like that. I'm not sure exactly why. All that seemed to matter was to modify just the one entry, just this directory, and everything else is is fine. And the new list is just as it was originally for that directory. So one thing I was correct about is that it was added first, and it didn't add 2 entries as these have. I'm thinking about this here, and it looks to me like whenever it's a generic flag in the access mask, then there's inheritance information, right? Standard access, nothing about inherit. Generic access, inherit, right? And that's true for all of them. Now the one that I added had inheritance information for standard breaks. Now maybe that's what makes it explicit and have the black check mark. I don't know. But that seems to be the only difference. Well, other than that and the fact that there is only one. Now the way I do the denial, which was using the method I was already using, that's the give. Sorry, the denial uses this set entries in ACL. Okay, so you get the pointer to the old list, and you specify a list of explicit access entries. Now this explicit, I don't know if that really means that it has to be explicit. The mode here doesn't have to be explicit. So now they're modifying the list, or I mean this function is modifying that list in whatever way it does. For the granting, I do it by hand. So what I do is I get my list of access control entries. I walk through the list and I look for something that's an access denied and whose trustee ends with the word users. So if I see a denied and users, now I probably should have that, right? Since that's the one I'm getting rid of. But whatever. Okay, so maybe it'll get rid of another denial at worst. So now I remove that from my linked list. If I don't remove from the linked list, I add to a number the size of the that particular entry. This size here is the size of the raw data that would be associated with that particular access control entry. Now I have to build a whole new access control list. So first thing is the header, which is an ACL, and I just added a little bit to this function to extract the previous header, so I don't need to know what to fill in for anything but the count. I just want to change the count and the size. So the count will be whatever is left in the list. The size will be whatever I've added up. It starts out at 8 and it's added. For some reason, plus equals gives me a warning I can't get rid of, so I have to do this. It says plus equals warning conversion from int to word. And so, there's something about plus equals that automatically converts things to integers. And there's no, as far as I can tell, there's no way to silence the warning except to explicitly do it as an integer and then cast the integer result as a word and set it. Now, so I have the count and the size and whatever else is in that struct, revision number, whatever. These are just padding. These things are for padding, apparently. And now I malloc that amount of data and put in my usual auto-free, which for some reason doesn't like this type of pointer. It's happy with any other kind of pointer, but this kind doesn't like. We don't understand that. Why does it complain? Complain. It works fine. Why was it compiling access control 1? Oh no, it's not. Hell looks like it was. Anyway, there are some bugs with this compiler. That's just a type def ACL. Oh, it's backwards, I see. PACL is a type. No. ACL. I think it's the way that this is written. Like, if I move this, actually, this is my file. If I move that like that, I wonder if it'd be okay now. It's nice having those 4 files. Sometimes little things come up, and since you know it's local, you can edit it. It's okay. It would be a compiler bug if it fixed it. No. No, but you see this auto-free pointer macro works with, P security descriptor, has no problem with it. That's just a O-type P4. Never mind. Okay. So now I allocate the memory, copy in the header, and then I'm just using a thing that goes steps by ones to save myself from another headache. and then keep appending and appending the entries one at a time until I get to the end. Now I thought that I would be able to just set it, but I thought I could just set file security with the new security descriptor, but it failed. It failed. It wouldn't take it. Again, it had to be an absolute format, and so convert to absolute format, and then I can set. Then now I can copy. I can create a new list from my absolute list. I can make a new absolute discretionary access control list, and then this thing succeeds. I don't know why it has to be like that, but I would think that if it's supposed to be a contiguous block of memory, perhaps because the size changed, then it wouldn't take it, right? Although, I could have tried something else. There's another thing in the header here. There's something which says unused space, or something. Used space and unused space. So you can leave it the same size and leave a hole, and that might have worked. So it's possible I didn't have to go through that step. But the point is that I didn't have to set any explicit access or call any special function. Just having all of the data available allowed me to construct a whole new security descriptor object, and unfortunately I had to go through a couple extra steps, but it got rid of the bad entry and fixed it. So now I keep saying that this started with me wanting to know about this string thing, but really the first thing that made me want to look at security was this function, which I copied from the MSDN, and I don't know why I need it. I don't know what the security risk was. So that's still a mystery. I can see now what this is doing, although I don't know this one. That would be container inherit, object inherit, container inherit. And I don't think I have container inherit in my list. Add inherit flag. Container inherit. Child containers inherit base. Object inherit. Non-container. Oh, so both containers and objects inherit. Okay, and what are they inheriting? They are inheriting generic denial of generic access. BG must mean built-in guest. AN must mean anonymous. Access is granted to authenticated users. Read, write, and execute, but not all. And all to administrators. Be a built-in administrator. So I'm getting the lingo. I don't know it goes in these ones. I know this is that flags mask. This is obviously the targeted group. But I know that you can specify an individual, and I know that you can specify an SID value, I'm pretty sure. Sometimes you can specify a GUID, globally unique identifier or something. And those are those funny weirdo values you see in the registry. So now it's back to the documentation and try and decipher some more of these words. Obviously, learning some of these words has helped. I don't know what a primary group is, for instance. I know what all these things are now. Now, see, these functions just add access control entries. And there must be, and here's a delete, right? I did it by hand. I'm not sure how to use that, but I'm sure that's just what I was doing. Here is that's probably used when a thing has holes. Now this could be useful. But I'm not really looking for useful tricks. I just want to understand them. I want to understand all the things here. Like one of the things I used to have was I used to have a function called add. What was it called? Add privilege. Add privilege. And it just took one of those special strings that you specify a kind of privilege level, and it would add that privilege, and you didn't have to do anything else. Just pass in a string, and it would add that privilege to your program or whatever. I haven't been able to do that again. One of the things that happens all the time when you watch this, when you look at this stuff, is something called impersonation. At some point, in a lot of the examples you see, there will be a call to impersonate either a user or another type of object. Like there's one point where a call is made to impersonate a name type, and then that caused that thread to have access to something or other, right? And there's even a function called impersonate self. So you can make another copy of yourself and have it try and do something. And sometimes that will allow you to call functions that previously you would have failed. And I'm not, so I don't understand this impersonation stuff at all. I have no idea what that's about. And I think probably there's got to be something about it. Set privilege. Yeah, it was something like this. Now, this, I tried this, of course. I don't, they don't tell you what this access token is. Enable a privilege, like what's an access token? How do I get an access token? Where does it come from? I know that. Now see, what's this? What's an LUID? A locally unique identifier. 64-bit. Unique. It's unique until the system's restarted. So a temporary SID sort of. Now there's this local security authority, which is a whole other layer below the regular security layer, and that's got all kinds of weird functions. I wish I could find one of those examples where I thought I could use this to get a token, and it failed. Well, I don't know if that failed or something later failed, and then I did this impersonate self, and it succeeded, but still. It still didn't help in the end. So here's the next step for me. I want to go and try and understand this topic. So I'm going to add this to favorites, and I'm going to start going through learning about tokens. That's kind of the wrong place to start, because this already assumes you know what a token is. But I might be able to work my way back to, how to find out what is a token, how do you get one, where does it come from, how is it used, all those things. These tokens are the things that I believe are, going along with the analogy of the business or the office. That would be like your pass card, like that. If you want to enter room 6, you have to have such and so. You have to be a level something agent or something, and so you have to have a special token in order to get in there. Access token. Whenever they talk about tokens, they talk about access. Access tokens do not support the synchronized write. See, now it's confusing. Token duplicate. Here's this impersonate. Attach an impersonation access token to a process. And there's a lot of this impersonation stuff going on. And I'm not exactly sure why. Okay, well, so that's what I'm going to look at next. See ya.